This is going to be something interesting because we are going to try live coding on our summit. And doing that will be Marek and Bartek, who will be showing us how you can do better test-driven coding for AMMs using Waffle and Buidler. So I'll have them kick it off from here, and I'll let them share their talk and their demo. So please welcome Marek and Bartek.
Hi, Eric.
Hey, thanks for having us. We're just about to share our screen. Off we go. Okay.
Good. So, hello, everyone. It's absolutely great to be with you here today. And what we're going to do today is we're going to do a live coding of distributed exchange and automated market maker model. And we're going to do it all in just 15 minutes. So how are we going to do it? Let me perhaps hide that first. Okay. So how are we going to do it? We're going to use test-driven development. So we're going to write tests before we write our implementation. And we're going to use ping-pong pair programming. So we're going to keep switching keyboard as we write the test and the smart contract code. The tooling that we're going to use is typical modern smart contract developer technological stack. So we're talking Waffle that was developed here at ETHWorks for testing smart contracts. We're talking Buidler for running the test and building the whole thing. We're talking about Ethers.js that was created by Richard Moore for connecting to the test node. We're talking about type chain created by Chris Kachor that gonna gives us strong types in our TypeScript tests for the smart contracts within the Solidity. And finally, we're gonna start with Solidity template that was created by Raul Setran. So, what is automated market maker text, you might ask? Well, the model is really pretty simple. Think about a single contract that represents a market, a pair of ERC20 token. We're gonna call it Plume and Kiwi for the purpose of this presentation. And you have really only two operations. One, you can modify liquidity. In our case, just add liquidity. And the way to do that is simply call a function that's gonna send some of both of the ERC token, and those ERC tokens gonna be added to both pools for each year, for both pools for both tokens. And of course, they need to be sent in the right proportion. And there is a second function used for trading. And again, it's very straightforward. What it does is it allows you to send a little bit of ERC20 token and add it to one pool, while the subtracted amount from the second pool goes back to the sender pocket. So off we go.
Okay, so here we are with our 15 minutes. We're gonna talk fast, write fast. So pay attention and stay tuned.
Wish us luck.
Wish us luck. So Marek right now is implementing our very first contract, which is gonna be a market. It's gonna be only the empty hollow of the contract, and we're gonna go straight to the test. We're gonna write the first test just after initiating the file.
So when it comes to test-driven development, one of the hardest things is always writing the first test. As you're gonna see, I think it's gonna take us roughly half of the time to write the very first test. So, and many times when you're doing that, it comes the question, what is the simplest test? What is a simple, reasonable test that you might write? So in our case, and in general, when it comes to working with smart contracts, the very first test is usually the one that deploys the smart contracts and check if they were deployed and initialized correctly. Now, if we would like to write it all at once, that would be quite a lot of work, and that would be quite a big step. So we're gonna start with just one very simple thing, which is deploying the contract without even initialization in the very first iteration. Now, what Bartek is doing is he's writing this very first test, and here already comes time chain into play. So what we're gonna do is what Bartek already did is he compiled the smart contract. So the smart contract is compiled, and the types in TypeScript for the smart contracts are already generated. In addition to those types, the factories for every single smart contract are generated. In that case, in our case, we have a market factory that can deploy the market. Now the market factory has its type, and the market has its type. So when we're gonna call functions on market, we're gonna see both suggestions and errors if we try to do something that should not be happening.
Okay, so we have our first test already passing, which is only deploying the contract, and now we need to start implementing the actual functionality of the market. So we're gonna pass 2 tokens to the market, which are gonna be exchanged on our market. And we're already gonna create, of course, we need to import an ERC20 interface from well-known and loved Open Zeppelin. It's gonna be / okay. And probably we're already gonna also implement getters for the stored pointers. So we go.
A little bit long, a little bit tricky, but
that's right. And we're gonna create 2 variables which are gonna store pointers to these 2 assets that we're gonna trade. We're gonna make them public, I guess.
A little bit copy paste, feels a little bit like cheating.
Feels like cheating, but
I think you will forgive us.
Yeah, and let's make it public.
Good.
All right.
Now let's try run tests. I think we need to reorganize the screen a little bit. Yep. Running tests, and we expect them to fail because we're obviously not passing the tokens to the contract. Let's see if that's true. Well, we didn't even need to write the test. You can see when we compile the types, it already show us, okay, deploy obviously doesn't have the arguments that it's supposed to. So now it's the time to implement token.
That's right.
Let's implement token then.
Yeah, so we're gonna implement this one really, really simply and really in a very straightforward manner. We're gonna strike all the necessary pragmas, of course. We're gonna start contract, it's gonna be a token. We're gonna import, it's gonna be an ERC20 token, of course, and we're gonna import an ERC20 contract, this time implementation, not the interface, from Open Zeppelin again.
Good old Open Zeppelin, always there when you need it.
Yeah, our good old champ. Yeah.
And we're
gonna call an ERC20 constructor and ERC20 passing the names. Yeah, that's right. And for the sake of the demo, we're gonna mint all the tokens to the user, to the deployer of the smart contract. Is gonna be sender, and let's pass him 2,000 tokens, like for example. All right.
Let's make him rich today. Is there anything?
Yeah, /tokens. You're missing /tokens.
Oh yeah,
/token. Okay. So that should do. /token.
It's a singular already.
That's right.
Good friends.
Okay, so let's build it, and it's gonna be a proper time to deploy it.
Yeah. So so almost there. We are now. Now that we have a token, we need to deploy. We're gonna deploy 2 instances of the same token. One that's gonna represent Kiwi, one that's gonna represent Plume. And you probably already know how to do that. You need to use token factory again. Type chain comes very handy. So off we go, almost there. Token factory being created. And once we have that, we can create 2 tokens. Now note in line 16, we have we are using Buidler getSignage method that allows us to get an instance of the wallet that we're gonna use to pay for deployment. And yeah, remember about good old awaits, always there for you, waiting. And yeah, we need to pass parameters, and let's see if it passes. So I think we're gonna have our very first test passing in a second now. Let's see.
Okay.
Yes. So we deploy, but we're not testing much yet. We kind of deployed the contract. Well, the test didn't fail, so it seems successful. So we're coming to the very first question, to the very basic question: what should the first test look like? And very simple answer is it just should check if the contract was initialized properly. So in our case, all it needs to do is to see if both contract variables were set up. So test is almost done. And when we run the test, we expect the test to fail. It's fine. We expect it to fail, but when it does, we can actually jump to actual implementation.
Yeah, so that example might seem trivial, but actually this is a really important principle of the TDD method that you should, and you definitely should, write your test before the implementation. And that actually implicates many good characteristics in your development practices. So yeah, and I think that the implementation is already done, so we can jump to the test and see it.
And you can see Buidler is doing great work for you, because when you run tests, it knows if you change the contracts or not. So it's building contracts only when you need to. Boom! The very first test is passing. So off we go to implementing the contract. So let's write the first function. I think you remember from the presentation, we have a supply function, and the supply function.
That's right. It's gonna add liquidity to the contract. And as you can see, the flow is gonna look like this for the whole demo, and should look like this in the whole process. So you first implement the signature of the function, compile it, generate all the typings, and then jump to the test, and then continue with the implementation.
Yeah. So now the question is, what our supply function gonna do? Well, it's gonna add liquidity to our market. So it's gonna basically just transfer 2 tokens to some amount of the 2 tokens, the Kiwi and Plums, to the smart contract. How are we gonna test it? Very simply, we're just gonna call the supply function, send a couple tokens here and there, and then we're gonna check if actually the balance of the smart contract has changed and is proper. Now, when transferring ERC20 tokens, always remember about calling the approve function, otherwise, well, it's gonna fail. And boom, off we go, almost there. We're adding the first matcher, which checks if the balance is there. A quick trick, a little detail is we have a expect to equal. It's fine if on the left side, on the expect side, it's a big number, and on the right side, it's a number of a string, because Waffle already does all the conversions on the fly for you. So I think the test is written. We run the test and see if it's gonna fail. And if it does, it's good. It means we can start with the implementation, and it is failing, and it is failing for the good reason. So
okay.
now,
so we're starting with the implementation, and it's gonna be really straightforward. It's gonna be just calling the transfer from function 2 times. So first time on the X token, we're gonna transfer tokens from the message sender, from the tokens donor, to the address of the market, and we're gonna pass the X amount. And also we're gonna do exactly the same for the Y token. For the Y token, and we're gonna just pass Y amount. Okay.
Here we go. Let's see if that is gonna succeed. So I think we're coding now for almost 10 minutes. And if the test is gonna succeed, we actually have a working initialized contract with the very first function. I know there is still plenty of things missing, but let's now jump straight to the second function.
And it's gonna be a trade function, which is gonna exchange our assets. So we start with the signature, we're gonna pass 1 argument, you need to type it. Yeah, that's right. And we, for the sake of the simplicity, are just gonna pass 1 argument, which is gonna be the amount of tokens we intend to sell, and we will allow only trading one way.
Yeah, and real solution, you would need to have function that trades both ways. But again, it's just 15 minutes quick demo, so we're gonna simplify a couple of things. I think we're almost there. So we're writing the test for the very second function out of 2. So you see that Bartek has to build the contracts because the environment didn't see the types. So that's a little annoying thing here, but it's worth investing this extra couple seconds into compilation because it really helps writing the test layer. So the trade function is really similar to supply function. The only difference is it doesn't just receive the tokens of 2 types. It receives the tokens of 1 type and send the tokens of the second time back. So you can see the test doesn't differ that much. And as you're gonna see in a moment, the implementation is not that very different as well. Well, you know, what we do in this DeFi all day long, we're just passing tokens around, right? So that's exactly what we're gonna do this time.
Okay,
we expect, you know.
So yeah, so let me just write the test. Okay, so we expect that the exchange is gonna gain 100 tokens, 1,000 kiwis. So exactly the amount that we pass to the exchange, and we expect the balance to drop below the 2000 of the second token.
So the test is failing for the good reason. So we implement.
Yeah, so the implementation goes as follows. First, we transfer the tokens that we intended to sell again to the market contract, and then we transfer from the exchange. So the exchange is gonna call the transfer function on the token, and yeah, what amount is gonna be. So we're gonna go with something really straightforward and really simple, just because the time isn't our best friend today, and it's gonna be a ratio of the token, Y token supply gathered, Y token liquidity gathered on the address of this very contract, this market, and it's gonna be divided. Yeah, it's gonna be a ratio. So we shall divide it. Yeah, and I know what you're gonna say, that not using safe math is not how you do things.
That's fine. This is not production demo. This is demo that shows you how you can code in the hackathon, but also if you have more time, it's a very good way to actually build a production code. Both ways, you very quickly get into something that is working and that is something that is fairly trusted. So boom, guys, we did it. It's already working. It's a ERC20 market. I think we still have a little extra time. So let's do something extra. There is plenty of details missing. So let's start with good old practice that, you know, every single important method that you call on the blockchain, every single function is supposed to emit an informative event so that you can gather the data outside of the blockchain, analyze them. So we're gonna start again with a failing test. We're gonna assume that supply gonna emit an event. We wanna see it failing before we actually implement it. I have a hint. I have a hunch it's gonna fail, and it failed, and it failed for the right reason.
That's right. So right now we're adding the event to the contract. It's gonna be against pretty simple. It's gonna be just a supply event with 2 units passed that's gonna signalize, and in the supply function, that's right, we're gonna emit them. Supply with X amount and Y amount. Okay, so that should.
The cool thing about pair programming is if you make a stupid mistake, instantly the second person can see it. We're running the test now, and let's see if it's gonna be successful. I think it's gonna be successful. Yeah, I think. Any second now, 3, 2, 1, and boom, it's working. And we still have time, so let's implement something extra. So we don't really have a lot of, we don't have any validation. So let's do validation. In reality, validation code in smart contract is oftentimes as much as half of the code or even more. So let's do that. Let's implement at least one require. We're gonna do a very simple require for today. We're gonna focus on reverting on trade function if it gets 0 token. Obviously, if someone is sending 0 tokens to the trade function, that sounds like an error. So we have a code. Let us see if the test fails, and if it fails for the right reason.
And it should.
Let's see. It fails, and it fails for the right reason. So now we say we require X amount to be bigger than 0, and if not, then this is the message we would like to.
Yeah.
It's a double quotes.
Double quotes. Exactly.
Automatically fixed. Let's see if the test will pass right now. I think it's gonna pass. What do you think, Barry?
Yeah, I think that we're doing really good. Actually, we could have just now started adding all these like bells and whistles, some fancy formulas for prices, etc. But for the hackathon reasons, I guess we're good.
I think we're good. I know what you think, guys. There's plenty of other things using sitemap, all the validation and all the stuff. If we only have another 15 minutes, I'm pretty sure we could do at least majority of that.
Yeah, and actually, if we did this in only 15 minutes, imagine what you can do in half a day or 1 day of hackathon.
Well, I think it's a month actually.
Yeah.
So this way or the other, quick recap what happened. We use Waffle. Waffle has all these great matchers. The 2 of them you've seen. So expect to emit with args, which allows easily check if particular events were emitted by a smart contract. Expect to revert with, which allows you to see if the function reverted for the right reason. And there's plenty of others. I'm gonna just show you one more, which is expect to be called on contract with, which allows you to check if your original function that you called also did other calls to other smart contracts and if they were done with proper arguments. And Waffle also have plenty of other features. I would like to raise your attention just to one more, which is mocking. Mocking allows you to deploy dynamic mock a smart contract that is a mock smart contract on the chain, and dynamically from the smart contract, dynamically from test allows you to
define the behavior of the contract.
Define the behavior so that you can easily test in isolation. We also use Buidler for compiling and for testing. Additionally, we use Buidler EVM, which is the fastest test EVM that is available on the market. Buidler have plenty of great features. They have automatic verification on Etherscan with single command. You can upload your code and
get it verified.
And get it verified on Etherscan. Very useful for hackathon. It has console log for Solidity, which allows you to quickly debug things. And I want to tease, there is a big announcement coming next week. So if you do anything related to DeFi or anything related to touching smart contracts that are already deployed on the blockchain, well, stay tuned. It's coming.
It's really gonna be big.
Yeah, the presentation is going to be available online. So we put all the links here, and I think we still have a couple of minutes for questions.
Hey, Marek, and
let us know if you have any.
There we go. I will just going to kickstart this. So thank you so much for this amazing live session. I'm glad that we were able to get something done live without Murphy's Laws coming in place. We have a couple questions coming in, so anybody who's listening on the chat, feel free to ask the questions right on the chat itself. But our first question is, to your knowledge, is there a good step-by-step visual debugger that can be used while running tests? And if so, like, what do you recommend people do? And the question also points out that the one for Azure needs Ganache to their knowledge.
Well, here is the thing. There might be, but we are so used to doing test-driven development that we never really use debugger. We never actually even use console log. I think maybe occasionally, because we write so many tasks that, you know, when they fail, we almost instantly know
what was the reason.
What was the reason? So on one hand, we would like to advertise, like it's a really cool way of creating smart contracts. On the other hand, we encourage you to explore, because I think some people are doing some interesting things. We just never kind of look into them.
Awesome. So we're waiting for a couple of more questions coming in. I just have to relay them with our live stream sync and lag. What other tools do you recommend that people try out if they are interested in just learning or being a better Solidity developer?
Well, I think the stack that we presented is very good for actual coding, whether it's on hackathon or production. If you just want to get into the thing, I think there is Remix.
Remix, yeah.
And there is also, what's the second one? I think there is a, now on Ethereum domain, there is some kind of, what was it? I don't remember anymore.
Yeah.
We can try to find it quickly. But there is so there are great tools online that we encourage you to explore, and maybe we'll just leave it somewhere on the chat.
Yeah, but these are again like online tools, but when it comes to the tools that you can actually use in your local developer environment, I guess what we've shown is the state of the art for today, like in our opinion, I guess.
Yeah, and we encourage to explore Buidler, and we encourage to explore Waffle and all the other tools, because there's plenty of features there that help on in everyday work.
Yeah. Great. The last question we have is, what do you think is currently missing from the Ethereum developer suite right now, and what will be your wish list of really great dev tools that would make everything easy for everybody?
Well, I think nothing comes to mind. I think I think there's a lot of polishing on features that we already have. So for example, tests are running pretty fast now, but I think they could be even faster. I remember originally, you know, tests were much slower. I think also, yeah, we were just discussing internally, the watch mode would be interesting.
Yeah.
We also thought about, yeah,
some deployment tool that will help you organize your deployment scripts maybe in some declarative manner instead of the imperative one, like similar to the tools that you see in the DevOps world?
We think deployment get much more complex than it was a year or 2 years ago. So deployment is potentially a space.
Yeah.
Awesome. We got one more question on our live chat, which is, to your knowledge, what is the best way to integrate your contract with existing DeFi protocol without directly testing on production?
The answer is you need to wait for big announcement from Buidler that is coming next week. So definitely follow those guys.
Yeah, and definitely this is gonna be the answer. But we don't want to spoil it right now.
We don't want to spoil it for Nomic. From Nomic guys. So Nomic Lab is the company behind Buidler that is doing a great job developing this whole Buidler solution and also the whole ecosystem around it.
No, that's wonderful. We can't wait for the Buidler team to also announce this on our Discord. They've been a great help to ETH Global over the last few months. So with that, I want to thank both of you for taking us through this live demo and giving us time to showcase how you can actually really do good